right, so I'm very excited to introduce our special guests today. We have John Petze from Sky Foundry and Marc Petock from Linkspring, and that's just one of the many things that each of them have their hands in. Both of these gentlemen have been around the industry for quite a long time, and Marc has hosted one of our previous events on cybersecurity. He was our MC, did a great job of that. So if anyone wants to go check out the archive recording of that presentation, it's out on our Building Intelligence Group YouTube channel. And John, this will be my first time being able to hear you present to us here as a Building Intelligence Group. And I was able to learn a lot more about your illustrious background by listening to James Dice's Nexus podcast. That a good history of where you had been. Both these folks have a background with Tritium, and moving from that to creating the landscape for data management through the Haystack organization and tools that are leveraged extensively with the companies that they are helming right now. So we're very excited to see what the perspective is on how tools like Project Haystack and metadata management are able to streamline the way that intelligent buildings are delivered and managed. So anything out of that you'd like to correct before we go on?
Yeah, let me throw out one thing. As I'm talking to you tonight, I am here in the role of Executive Director of Project Haystack, not Sky Foundry. That's extremely important to convey to everybody. Project Haystack's an open source 501c nonprofit. I am the current Executive Director, but I'm here in a completely non-commercial role, and this has been very important to convey that information on Project Haystack. It's not aligned with any individual company. It's not commercial technology. It's completely open source. A number of companies have jumped on this and dedicated a lot of time to it. But I'll be glad to come talk to you about Sky Foundry and SkySpark, but I don't think that's what you want. So I'm here today in the role of Executive Director of Project Haystack.
And I'll echo that. I'm here in the role of Executive Secretary for Project Haystack, not as Linkspring. And again, we always like to make these type of comments because we think it's important for the integrity of the organization. So glad we are able to say that.
Good, thanks. That's very germane because this is a group that's not about trying to let companies come in and promote their products. They've got enough platforms to do that. Really what we've decided as a group, we want to be able to promote ideas and educate people around the concepts that are enablers of the buildings. So that's a very good clarification. Thank you.
We like that. So you want me to go ahead? We'll go ahead and get started if you're all right, Brad. First of all, I want to, on behalf of John and myself, we want to thank the Building Intelligence Group for inviting Project Haystack here today. And we're delighted and excited at the same time to be able to share some things about Haystack. And but what we thought we would do, I'm going to take the first few minutes to chat about the role of data in achieving smarter buildings. And then we will go ahead and move into where Haystack plays the role in helping with data and achieving smarter buildings. So with that, John, advance, please. So thanks. So let's get started. So data, I think most of us on the call today know, is a building's most valuable asset. It's a must-have now, not a nice-to-have. And assessing and making use of it from the existing operational systems is critical. I mean, we cannot emphasize that more. It is critical to make any building smart or a building smarter. So where are we? We're in an era where today we can capture data from different sources. We can make it consistent, we can make it meaningful, and we can share and take advantage of it across multiple applications, regardless of what those applications are. Today's increased access to all the data that's within the built environment, within our buildings, is really empowering us to take advantage of it from anywhere and any device. It really doesn't matter if it's from the HVAC system, lighting, physical security, parking gates, so forth and so on. We can capture data from those devices and pieces of equipment. And by effectively utilizing all this data, we can create better operational and occupant experience. And I think that right there is the key value message for taking away. We can create better operational and occupant experiences. John? So at the heart of this, at the heart of data, data needs order to be useful. You can have all the data in the world, but unless there's order to it, you will never be able to take full advantage of the capabilities and the value that data brings. So having access to data is not the same as controlling it and making it meaningful to use. Knowing which data to collect and give it uniformity is definitely key. The challenge we have seen over the years has been determining what data is important, what is relevant. How do you standardize on it? You've got to be able to standardize on it, how to give it some kind of common context and streamline it to really unlock the data's true value. And again, that statement, that true value, there's different people within a building who have different need sets. A CFO may have one need sets for data, an engineer may have another, a project manager may have different needs. But again, it's all those needs are being handled through the standardization of data. So when you capture, process, normalize, tag, and analyze data, it enables this true transformation on the way we should be managing and operating our buildings. And I just want to throw this statement in here that from IBM, that poor quality data costs businesses in excess of $3 trillion a year, a huge amount. John? So the use of semantic tagging schema, such as Haystack, is essential requirement for making sense of data and utilizing it to its fullest potential, the data that exists. Interoperability between the systems that are in the building and data should not be a luxury anymore that only a few have. Every building should be able to have data, to be able to access the data and to be able to take advantage of it. We do have the tools today and the functionality available, and the need for the capabilities to be integrated within our buildings has never been stronger. And I think especially you guys in the engineering side are seeing this as well as you're working with your particular clients and so forth. As a data modeling schema, Haystack semantic modeling, our ontology, the tagging, the naming conventions, the taxonomies, they all provide this consistent standardized methodology for naming and describing data points. John? So if we look at it at the end of the day, what are the benefits to owners and operators? After all, for all of us, regardless of where we're at within the built environment and our place, it's benefits to the owners and operators. So we've put together a 4 here that I think is extremely important. So it contributes to a good foundation of data management plan. It reduces that overall cost of data maintenance. It provides a common linkage for data to be tied together and exchanged and managed consistently, provides an open, industry agreed upon standard and vocabulary and ontology for all the building assets and classes within the systems in a building, and improves the cost effectiveness of implementing analytics and other focus applications. We're going to, in our deeper dive into Haystack, we're going to go in a little bit more in-depth detail there. So today, just to give you a perspective where Haystack is, we're in excess of over 30,000 facilities globally in buildings such as commercial, office, and industrial, education, financial, government, healthcare, and medical. OEMs who manufacture equipment have adopted the methodology, and of course, retail. And just to give you an example of 3 case histories there with our utilizing the Project Haystack is Ford Land up in Detroit, the GSA, all the GSA government buildings now utilize the Haystack methodology for their whole data, capturing their data and managing their data. And again, education, I happen to be a favorite of this one, the University of Richmond in Richmond, Virginia, where I live. So with that, as I said, now we're going to really get into a deeper dive of Haystack. And with that, John, I'm going to leave it up to you.
Okay, thanks a lot. All right, well, the goal of Project Haystack is to make all this data from these diverse systems easy to work with. And, you know, the challenge here, let's start with that, is that most data produced by devices and equipment systems does not actually contain any descriptive information to tell you what it means. If you installed the system, you gave it the names, you know what it means. But if you didn't, and you take the data out of the system, do you know what it means? You know, and amazingly, the big problem is there has never been a standardized approach, or there wasn't in the past, of adding what's called semantic data, metadata. You know, software words, all it means is descriptive attributes, if you will, that define what a piece of data means. And one of the things we like to point out is Project Haystack is not a naming convention. There's a good reason for that. Names can't do the job. For example, Marc Petock, that's your name. Didn't tell me anything about him, age, address, type of car he drives, any of those things. Those would all be attributes of Marc Petock. Can you imagine trying to build that all into somebody's name? Well, it's the same reason names in control systems and the like can't solve the problem. And so what we find is when you want to use data from these different systems, the first barrier you hit is this manual labor-intensive process to figure out, well, what's this mean? What is this? Where is that sensor? What's it associated with? Right? And that is the barrier that our industry faces to effectively using this data, which we can show can be tremendously valuable. And it adds cost and it delays delivery of value. So I'll say that simpler. Any application that's going to generate value from data has to have semantic meaning. I don't care whether you're doing energy analysis, analytics, market-based commissioning, M&V. All right. So what's Project Haystack and how does it address this challenge? Well, it's a community of people and companies that got together to work on this problem, to address the need to have semantic modeling of data, to eliminate the manually intensive process, to eliminate the cost. That's what the organization is. We're 10 years old. It was founded in March 2011. We'll talk a little bit more about that. But now what is it? You know, how does it help this? Okay, we were saying, you know, Haystack helps us how? Well, what it provides is a standardized methodology, right? And a methodology includes multiple components, right? A standardized way to describe the meaning of data so that it'll be able to be utilized in other applications so that we can get value out of it. And it's built around the concept of tags. Tags, little snippets of information that, you know, they define the attributes. And, you know, I'll give you an example of this. You know, for some of you, maybe today even used Microsoft Outlook, right? When it was a fat client application. And if you wanted to organize your emails, what did you have to do? You had to drag it into a folder. And if you dragged it into the folder, that's the only place it existed, in that folder. But when the web-based email came out, it came out with the concept of tags. I can tag this beach photos. I can tag this relatives, summer barbecue, whatever. And you can search by those tags. You didn't have to take it and stick it one place. You can search by the attributes you care about. Tags really came out of the internet, and they work together with, so we have tags and we have a model of how they should be used. That gives us that methodology. But we can say it a lot simpler. Just think about it as a markup language for the data that comes out of systems. And let's use this example. Why can I point my browser at your red website and read what you published, right? Brad, we didn't have our engineers meet so that we could look at each other's website, right? Did they get together and share APIs? You're gonna need to code it this way. That's ludicrous, right? We didn't have to do that. Why does it work? Because long, long ago, in a galaxy far away, the industry agreed on a markup language, otherwise the web wouldn't work. It's called HTML. And HTML doesn't dictate what you put on your website. You can put anything you want on. What it does is provide you a standardized way to mark it up, to say, here's how I'm going to represent text and pictures and colors. Well, at a conceptual level, Haystack does the exact same thing for the data that comes out of our systems. It gives it the meaning so that other applications and human beings can understand its meaning. So let's go through an example. You say to me, hey, John, analyze this. You're in the data analytics world, analyze this. And you point me to a record in a system that might have a name like this, right? ZN3-WWFL4. I have no idea what they were drinking when they named it. Maybe it meant something to them. I'm sorry, Brad, I have no idea what it is. Well, it's got a number associated with it, John, 24.6. Thanks a lot, pal. That really helps me a lot. 24.6. Is that okay? Well, the first thing is units. What's the number represent? And I think this is one of the most interesting things about tags. Do you know that numbers actually have absolutely no meaning? Brad, thank you for inviting me and Mark. After this, I'm going to send you 100. 100 what? And as human beings, we take this for granted because we never deal with numbers without a unit because they'd have no meaning. So that'd be my first question. Brad, what's the units? Oh, that's degrees C, John. Oh, degrees C, huh? It's 24.6 degrees C. Look at a typo there. Okay. Well, I don't know. What the heck is it? Is it a room temperature, a zone temperature? Oh, return air temperature. Chilled water temperature, 75 degrees on a hot summer day. Not too good. But you say, oh, yeah, sorry, that's a zone. Wow, it's a zone. Well, 24.6, about 75 degrees. Might be a little warm, 76 around there. But you know, what's the schedule for this space? Because, you know, a night setback, that's fine, right? And you give me the schedule, and I go, well, you know, it'd be interesting to know what air handler serves it, what VAV box serves it. I'd need all these things to answer the question of, is this value of 24.6 degrees C okay? And we'd have a conversation. It would take some time. You might have to go look it up. You'd give me that data and I'd give you my answer. That's too slow. How do you convey these answers in a standard way, right? That's what Haystack accomplishes. So get a really simple example. Here's an example of Haystack tags that describe the meaning of a point in, you know, BAS system. You get the point name. Yeah, that's wonderful. HU1-SAT. Well, that one's pretty good. I might be able to determine what it is. But now how do we define it in a standardized way? Well, we define it with tags. Tags say it's a sensor. It's measuring a phenomenon. It's measuring discharge of what? Air. And it's measuring the temperature. And in this case, I've got degrees Fahrenheit. That's helpful. Those are what we call descriptive tags. But then I want to associate it with a piece of equipment. Well, HUREF is HU1. That's called an association type tag. It points to a record that gives us the information. And the tags are really that simple at their first level. That's what we're talking about, is defining it in a consistent way with tags. All right, so why? Why do we want to do this? Is I want to click my mouse and read your website. I want to click my mouse and get the data and know what it means so my application can absorb it and do something with it or create a report. That's why. So how are we going to get there? Well, here's some examples. You know, people say, well, what does this enable? And, you know, the quick answer is applications just work. Well, give me a little more detail. Well, how about a new generation of engineering tools that dramatically streamline project implementation? Hey, that sounds good. Example? I'll give you an example. Equipment graphics, right? I've been in the BS industry for a long time. And over the years, I have seen that drawing the graphics People spend more time and money on the 3D graphic shaded AutoCAD view with the spinning fan that's in the right orientation than they do on the control sequence to run the building right. I call it the tail that has now wags the dog, right? But what if by reading the tags of all the points in the BAS, the system will automatically auto-generate the graphics? That's happening today, eliminating all of that manual drawing. Another example, control logic. It can actually find the devices that it should be applied to. So I write a VAV control sequence, and then it goes and finds the devices by looking at things that are tagged as VAV boxes. And then at the higher level, it allows easy integration of software applications, analytics, reporting, et cetera, because the apps can connect to the data and understand it just like I can connect to your website. So, little history. A number of people got together and founded this organization in March 2011 after finding out that there was no standard out there. And then we started the organization fully open source, published everything we did, created working groups, bring people together. In 2014, we established a 501c. It's really important to mention there's no cost to participate in the community or the working groups. You can go to the website today and you can download every piece of information at projecthaystack.org that the entire worldwide community has developed with a click of a button. There is no cost. Now, how do we work? This is true open source, which has actually been one of the things that's a little different for the buildings, controls, and HVAC world, which is used to very prescribed standards. It's done in a collaborative open source model. Now today there's over 2,000 registered community members, and a key point about this is the standard gets advanced by collaboration. People come together to add to the vocabulary, to add to the equipment definitions, to add to the ontology, which is the relationships of equipment systems within, or equipment devices within a system. So collaboration is key to our mission. All right, so let's talk about the development, because I think it helps the understanding, because we all started out trying to solve this problem, and we started with development of a vocabulary of tags, right? And we said, we're all going to use this tag to say it's an air handle. That means something. We're all going to agree on that, right? And this, means discharge, and this means sensor, and by these tags we mean these things. And so we started with a vocabulary first. And if everybody used that vocabulary, then I could read your data, see the vocabulary. Oh, okay, I know what this is. I know that is a zone temperature sensor versus a discharge air or return air sensor. Okay, so that was phase one, and that really helped people. And now there was something to help solve this problem. But our use of it, our understanding of the challenge, and the request to do more grew. So one of the first things that we introduced in the next phase was a REST API. In other words, a standard software API, so you could query a system, a software application, a device to deliver its Haystack tags and information. And that provided a good standard way that people could build into their products. It wasn't just defined as an API. There's a whole variety of reference implementations in C++ and Java and JSON and on and on and on. So people could say, hey, I can get up and running with a Haystack service. Okay. We also added lots of new data types, increased the vocabulary, because we had a working group structure. We made it more formal, and people came together and said, hey, I saw your proposed model for the current model for electric meters. I know a lot more about electric meters. You missed all this stuff. Great, come on in, help us. Hey, I don't see anything for fan coil units, or I think you don't have a rich enough model. Come on in and help us, right? And so it really gets developed that way, and that's really important because it's going to constantly develop. It's going to develop forever, because as we know, there's all types of different systems and buildings. It doesn't stop. 2018, an important announcement we made was a collaboration between Project Haystack, the BRIC Schema, which is another organization working on this problem, but kind of from a different viewpoint, and ASHRAE's BACnet committee, right? Collaboration was the main goal. All right. Through that collaboration, a year and a half of collaboration, meetings and stuff, we introduced Haystack 4 in 2019. 8 years of learning, experience, input, plus the collaboration. And then what we extended it to was more than just a vocabulary, but what's called a taxonomy, a hierarchy, right, of the relationships of devices and systems, and an ontology, which is the relationship between devices and systems, like that room air temperature sensor, right, related to a schedule, right? It's obvious that it's related to the VAV box, it's connected to it, but it's also got a relationship to a schedule, right? So capturing relationships. One of the other things we did was implement what's called RDF, Resource Description Framework. That's World Wide Web deep software stuff, but it's a way to express data and relationships, and we built that into the standard. And then most recently, just last week, Project Haystack was awarded under the DOE's new $83 million initiative to increase building energy efficiency. Project Haystack won an award, a sizable award, to help bring funding to the organization to advance the standard even more, create validation, verification tools. That was just announced last week. Other than the DOE announcement, well, we haven't got, Mark and I haven't got the press releases out on this, but it's a really big deal for the organization. All right, so we talk benefits and values. Let's break it down a second time. And you find we're going to revisit a lot of these topics because I think once as we gain a bit of an understanding, we should revisit these questions. Why does an owner and operator care? Faster timed outcomes. I think that's actually the most important. I've got a building. I want to implement what? Analytics, maybe? If you don't have to go through that data mapping, data wrangling, manual process, you get to your end result faster. Right? And as Mark said, you also get much more control and understanding of your data because you've got a uniform way to represent its meaning, which often exposes lots of gaps you have, like, hey, nobody knows what these points are. Bob left the company, I can't find the manual. Someone start walking the building, right? This happens, right? I can see that this happens, right? For facility managers, their data is now consistent so they can work with different vendors, right? And say, no, we've got all our data. It's all in this format. You'll be able to easily use it. So you're not going to have such high costs in there, right? So it makes it much more cost effective to perform analytic related things, right? M&V, monitor-based commissioning, analytics, fault detection, it's essential. System integrators, why do they care? They spend less time doing what I would call frustrating and unproductive work that the owner really doesn't understand and doesn't want to pay for. What are you charging me this for? What are you doing, right? It simplifies the whole workflow of working with data from different types of systems. And it makes it repeatable. You've got your data tagged. You can today work with application A. A new application comes out next year, you're going to be able to get your data into it much more effectively. And for OEMs who make systems, the value is they can say, look, you buy my system and you've got an assurance of data interoperability. You've got consistent and faster configuration of the tasks. And again, anyone can use it, open source, no cost. So people say, well, great, but this is a new standard. It's not supported everywhere. Absolutely true. Right? The industry needs to move to improving lots of things, and this is one of them. Well, John, how can I use Haystack? Well, let's look at the picture on the left. This is the ideal. Someday, devices will have the tags directly in them, so when you connect, you get this standardized format of data. I call it like plug and play for my printer. I can see other people on this call who have gray hair. That means you used to have to connect a printer and get floppy disks and put them in and load the driver and make sure this worked, and it didn't work, and you contact, oh, you've got the old driver, you need the new driver, and all this stuff. Does anybody do that anymore? You buy the thing, you plug it in, and it announces itself with standard services. Sounds a lot like semantic data, right? So you can build it in the devices, but yeah, not everybody has it there. So we look at the middle. This is probably one of the most common ways it's used today. Network controllers, global controller devices at that tier of the system typically have more software flexibility. They have components. You can add attributes. So you tag it there. Okay, well, you had to do the work to tag it there, but guess what? Now upstream for any other analytics, visualization, mobile apps, whatever you want. You never have to do it again. You dealt with it once. All the other applications don't have to go through the data mapping manual. Well, John, we don't have global controllers that have that flexibility. Okay, you'll use a tool. You'll tag it as it goes into a database. And still, you've solved the problem for upstream later use. All other applications that are going to communicate with that data now have the tags. So over time, we'll move more and more down to the end devices, but you can use Haystack today and it's used in all these different ways. And we'll talk a little bit more about the ways it can be used, because one of the things people think is, well, who makes a software application where I can capture the tagging information? Well, a lot of companies do. My company does, but you know what? You can capture it in Excel. You can capture it on Word. You can capture it on a yellow sheet of paper. The tags are human readable and machine readable, so you can use this consistent formula even if you're walking around a building with a clipboard. All right, a little bit of history again, adoption and support. Some of you may be familiar with the Realcomm and IBCon conferences. When it was introduced, it won the 2013 Digi Award, right? We have done now 5 conferences. The last one was virtual and finished in May, but every 2 years, it's a biennial event. We do conferences where working groups come together, people come together, education and presentations happen. As I mentioned, we have a formal 501c. And one of the most important things I think we have is the Haystack Connections magazine, because that's articles from the community about how they've adopted Haystack, why they've adopted Haystack, how it has helped them achieve their goals running their facilities. And you can find lots of them on the website. You can go to project-haystack.org. That is actually the technical, more developer-oriented site, but it's got a link to what we call the marketing site, and it'll take you to all kinds of resources. White paper with CABA, guide specifications in English, French, Chinese, and I think another language out there, Mark, if I remember correctly. Examples, detailed reference implementation. What's a building look like? What's an entire tag model look like for a building? We've got examples out there. And then lots of what we call reference implementations in software, lots of different applications, references in different languages, coding languages, etc. At the organizational level, there are founding members. My companies, Mark's company, we're founding members of this, and we are on the board. It's run by, or it's directed by a board of directors, but we have associate members. You can see the logos there. Lots of companies who use different technologies, compete with each other. They use Haystack because this is a necessary part of utilizing data for value. So there's some links there, and you can find it pretty easily, project-haystack.org. So that's the first level of introduction. Quick takeaways. This is real. This is deployed over 30,000 buildings we know of. And by the way, it's open source. We don't track who uses it. That's what we can do from talking to people and getting stories from the industry. It's proven. And it's completely open source with zero cost to use it. And it's extensible, right? So there's a standard vocabulary, standard equipment models, that's all there. But the methodology is completely extensible, so you can add your own tags to capture whatever attributes you want. Orientation of the sun, the color of the building, the year it was built, all these things. It's a standard way to capture attributes about data so that it can be transported and communicated in a standard way. The next one's important too. It's very lightweight. People say, well, I got a very small control. I couldn't put it in there. Wrong. We have people putting it in temperature sensors. They're communicating sensors, right? But if you have any level of microprocessor capability, you can put the necessary tags for that device in it. It is not a high overhead issue, right? And like I said, text files, Excel worksheets, etc., because it's human readable and machine readable. And it's understandable by the people who do projects. As an engineer or technician setting up a BAS by adding a couple of more fields to your point, when you define it, you've now added standard tags so that that work doesn't have to be done over and over and over again. That's really one of the most important goals of Haystack, is to use it at that level. So I'm going to stop there. That's the introduction to Haystack. And, with the time we have allotted today, we've allowed to go into further detail, but I don't want to do that until, people have had a chance to ask questions. Hopefully some have come in there, Brad.
Chat has been quiet. Why don't we go live on any of the questions folks might have at this point? You answer one of my questions as a consulting specifying engineer. How do we put our specs together and enforce them for Haystack? You mentioned a guide spec. Is that my resource?
There's guide specification there that we've produced as a resource. And then, here would be a good example how the community works. You look at the guide spec and you go, that's pretty lame, John. It's helpful. And, as soon as you say that, I'm going to say, I think you just volunteered for a working group to improve the guide specification. Brad, this is phenomenal. That's how this works. And that's a really important point to understand it. But yes, we've done work. We've put it out there. We've had a number of revisions to it, but I'm sure you will find things that you would want to improve. But there's no paid staff to do that. You got to come in and go, here, I've used it, and here are the things I think we need to deal with to make it effective for me and how I do my business.
And then let's say I take a look at that guide spec and I understand, 50% of it. Is there a community? Is there some place that I can go to where there's active discussion around that?
Discussion forum on project-haystack.org that is all levels, from introductory to deep technical conversations, and you post a question there or suggest people start a working group. That's the communication for the community, the forum. You do have to register for an account. There's no cost. And then you can go on and post messages and contribute to the conversations.
And I'll just add that there are folks from the consulting engineering community as part of the Haystack community globally. So, which is very encouraging. And, again, it's all the groups that affect a building, a smarter building or whatever, are all part of the community here.
Yeah, that's a really good point. So, you go to the website, go to the marketing tab, take you to the marketing website, read some of the issues of the Connections magazine. You're going to see articles from consulting engineers. Why did they start requiring? Why did it help them, right? I'll give you another example. The GSA, it's in their spec for automation systems that you're going to tag it with Haystack, right? So, there's definite, you're going to, if you're new to it, this reading and learning and you're going to take to get up to speed with it. We're constantly trying to improve that and working on some new training programs and whatever. But yeah, that information's there. I can try to switch my share to that website, or everybody can just go and click on project-haystack.org. You'll get an idea of the resources available.
I have a question, gentlemen. This reminds me a lot. I come out of industrial automation, and so I see a lot of similarities with the tagging and such, and we're starting to see more and more of that aligned in the building and construction trades as buildings get more intelligent and they become more like a specific kind of factory, right? With lighting systems, all the different subsystems that are connected and they're communicating, and you have to monitor them and make sure they're efficient and on and on. And one of the questions that I popped in earlier or late this afternoon as I kind of registered to get access to this thing again was what inherent, and maybe you're going to talk about it here in the little deeper dig, cybersecurity support that of anything that you may have built into Project Haystack. If you're going to talk about it, I'll wait.
No, I'll address that right now. We'll probably touch on it. I mean, first of all, Project Haystack does not define your communication protocol. There is a REST API, and if you implement that, that has an authentication mechanism, a standard published open source reviewable authentication mechanism. So if you say, I want to make my software application, my control system, a Haystack server with the API, it includes a complete authentication mechanism that's been reviewed and out there and seems well accepted, right? But Haystack tags can be conveyed, like I said, in Excel, right? Hey, I'm going to give you, all the points and all the tags. I'm going to give it in Excel. And I guess I'd ask you, are you going to lock it up with a password? That's your choice, right? You can convey it over other communication protocols, and you'd be at the mercy of whatever cybersecurity constructs they support, right? So it doesn't impose that. If you're going to make a server that talks the API, there is a complete standard authentication mechanism in the specification that you should implement.
And in
Agreed.
addition,
Yeah,
I
go
was
ahead,
going to
Mark.
say, thanks. In addition to what John just said, there is a working group that is all about cybersecurity. And obviously, again, what they're working on and everything is open to anybody to go in there and take a look at it. But to your point, cybersecurity is important, and the fact that the community, members of the community we do have a working group, I think, to address issues in and around that.
Yeah, good point, Mark. Thanks.
Thank you. And it sounds like with that's one of the things that I've been trying to promote, is that single factor authentication is not enough. And so being able to have something at a RESTful level, and then something as a system level, so that you have multi-factor authentication.
Yeah, that's a decision of the application. Haystack doesn't, you don't have to, that doesn't impose that on you to use Haystack tagging, right?
Right.
Okay.
Right. Thank you.
Sure. Anything else, Brad? Come in, please. I'll be glad to continue, but I want to make sure there's time for discussion and questions, and feel free to ask. That's
Yeah, no, I'll just make a reminder to drop any of those questions in the chat right now, and then we'll open back up for live Q&A after you wrap this up. Why don't you keep rolling through here? This is good stuff.
All right, you guys want to go deeper, eh? Okay. So big thing, after 8 years, we implement, and all this input and collaboration, we implemented Haystack 4. And I took the standard deeper. It took her deeper into data science concepts, data management concepts, right? The easiest way to understand Haystack is a markup language with defined, tags of defined vocabulary. But if you go and look at a modern website and read the raw HTML5 script behind it, it's complex, right? And that's because HTML evolved to allow people to do different things as more and more people used it. So HTML5 is very different from the HTML we saw in 1997, for example, right? Same thing here. New requirements, new development, Haystack 4. And so I thought we'd spend a little bit of time on that. And you know what? All of the information on Haystack 4 is available, but I know it was too long. I didn't read it. So here's the summary version, right? TLDR, the young people call it, right? All right, so the core concepts of Haystack 4 is you have a vocabulary. We've talked about that, but these are standardized descriptive terms. We've agreed what they mean when we use them. A vocabulary. Then there's a taxonomy. It'll define hierarchies of relationships, and then the concept of ontology, relationships between things. And this all leads to the real payoff, inference. Queries can infer information by exploiting all of these concepts of vocabulary, taxonomy, and ontology. So start with the vocabulary. And again, every bit of this and all the detail, the total vocabulary, the total taxonomy, the ontologies, it's all on the website. So Haystack today, we were very focused. We looked at the work of the semantic web, if you've ever heard of that. And, a lot of that came from deep software architecture, deep software theory. And we took a very important tact with Haystack, which is we have to make this usable by the people who implement the systems we're talking about. It has to be relatively easily for a technician to understand that, I'm defining a point in a system, and I used to only have to define 3 things, but now I got to define 7 because I got to add these tags to it. So the dialog box got a little bigger. And that means that it had to be human language oriented, right? Terms like air handler, air handling unit, rooftop unit, those are all different terms. So we have to have a standard term and saying, that's an AHU. Now, there can be a lot of subtypes of that, but we said AHU, that's what it means. Okay, so there's a library of all the terms on the website. Well, the concept of a taxonomy is a hierarchy, classification trees, right? And, you know, we think the good old high school biology is a great way to express this and kind of wake up our minds from stuff we learned long ago. Remember, there's kingdoms and phylums and classes and orders and families and genus. And the last thing is the species, right? Let's look at a picture, right? The kingdom is animals. This is a taxonomy. The phylum is chordata, ones that have a spinal cord. A class would be mammalia, mammals. And within that, we've got carnivores, right? And under carnivores, well, we're looking at dogs. And under dogs, we're looking at a subset of dogs, the canis dogs, right? Basically domesticated. And you know what? I care about one of them, right? The wolf, okay, whatever. So this is a biology taxonomy, and we apply this to systems. And extensive work, man years of effort were invested to define a taxonomy of the equipment in this type of a model. Okay, here's an example around phenomenon, things we want to sense. This is a taxonomy. You have phenomenon, that's a scientific term, and under that you have substances, which could be a fluid, gas, or air, right? And you have liquids, a subset of that, which could be, and examples are water and chilled water. That's a taxonomy in Haystack around stuff we want to measure, monitor, okay? And then we talk about ontology. And this is a little harder to grasp, I agree, as I've gone through the learning of this. You know, we didn't all walk into this knowing all of this ahead of time. We walked into it knowing we have to solve this problem to make data useful across applications. And this whole idea of an ontology and the relationships between terms, right? Because taxonomy only captures the hierarchy of relationships, but ontology is the relationships between things that are not within a single taxonomy tree. So here are examples. An AHU contains a discharge duct. And a duct conveys air, and a pipe conveys fluid, right? And a boiler heats a fluid, an air handler heats air, and a tank stores some type of substance, a battery stores electricity, and a valve regulates fluid, whereas a damper regulates air. And a pump moves fluid, and a fan moves a specific type of fluid, air, right? Those are considered ontology relationships, right? Because they're relationships between things. Between, what's a boiler do? What's an air handler do? What's a tank do, right? These are the relationships between things, not necessarily between equipment systems, between things that we define with Haystack tags. Okay, and where does this lead? It leads to being able to infer things from the data we have with the tags. We can get to the thing we want, which is to be able to understand relationships, performance, faults, etc. So we get to inference. All right. The concept. With inference, we can have smarter tools and applications. We can have more powerful query languages so that we can understand the impact of a valve that's controlling a substance, a liquid, hot water, not closing all the way, causing an impact on the performance of an air handler, right? And the problem is human beings do this pretty automatically. And you have to kind of break down, how did I determine something was wrong with that air handler, right? Well, I determined it because I got 30 years of experience. Not good enough, John. Let's break it down. How did we get through the mental steps? Like, you're going to teach a 10-year-old how to diagnose that air handler. You may not accomplish that, but think about how you would have to break down all of the elements and relationships. That's inferring things across known types of data. So that's what Haystack 4 brought to the standard. It brought It extended the vocabulary significantly based on input. It was the work of the community to create taxonomy relationships of equipment systems like air handlers, fan coils, VAVs. Those are all types of air moving equipment, right? And then the ontology, the models of, if you define an air handler, it has all of these things in relationships to other things, which allows us to do inference. We also added support for this RDF resource description framework method of linking data, which software architects, engineers utilize. And the result is this standardized method that we can make data meaningful to humans and computers that we believe, and based on all information so far, can model any building, any equipment system, and the necessary relationships. That doesn't mean we're not always adding. I'll give you a good example. One of the newest working groups, actually launched by Daikin, is to build out the vocabulary, taxonomy, and ontology for variable refrigeration systems. Daikin, one of the world leaders in that, has come to an understanding and a believer that this is important for their equipment systems to be able to be part of other systems and convey data. And so they launched a working group and are pulling people together. They are leading the domain knowledge side. They know VRF, right? And the other Haystack community members are leading the, well, no, that's how you, not how you do, that vocabulary isn't clear enough, you're duplicating, and here's how you set up a taxonomy here, break it down, right? Like I said, how we break it down for, for someone if we were trying to teach them about an air handler and all the intricacies of the operation. So that's a little bit more about Haystack 4 and the significant expansion of the standard, both in the equipment models, the vocabulary, and the software techniques that can be exploited by people building applications. And that's what I get to offer. So we'll be glad to try to, continue to answer other questions if any of others have come up.
I have a question.
Yeah.
John, Mark. I saw one of the supporting organizations was the European KNX group.
Yeah. Mm-hmm.
Big building automation, OEM support, and standards for connectivity and communication. And I'm wondering if you've been approached by the IEC about anything.
Have not. I'm not aware of anybody reaching out from the IEC.
Okay, very good. Thank you.
And again, to add to that, we would welcome it. Obviously, all of these types of bodies, again, it's open community. We would welcome, these types of organizations to become part of Haystack.
Yeah, it's a good point, because earlier this week, I did a presentation for the International Building Performance Data Interoperability Organization, a 501c out of Europe, IBPDI, about collaborating together. They're solving a certain part of problem in real estate, and the conversation was great. They go, oh, you solved that part. We thought we were going to have to build that all. Let's work together, right? Now, we haven't signed anything, but that's the type of collaboration, that we're fostering and hopefully doing it. But that one hasn't come across that I've seen.
Well, I connected with you on LinkedIn, John, so I'll pick up some conversations that way. Yeah. And share some contacts. Mark, I think I reached out to you. No, I think I tried to reach out to you, Mark, but you're only asking for followers, I believe, at this point.
Well, that's well, I'll need to change that though, Tom. So thanks.
And this is so important. I think this is one of the barriers people have seen. I've been doing this for 25 years, and where did we get our standards? They were handed to us, somebody hashed it out, and we must follow it. They were highly explicit, right? You have to have your device speak this way to conform to that. That's great. Those are wire protocols and other things that can be prescribed ahead of time. This is our collective industry of the built environment, learning the number one, the problems and then the solutions, and Haystack's a methodology that's extensible and malleable to do it. We continue to evolve and learn more. And that actually puts some people off. They go, well, no, I just want you to hand me the book all done. Well, we're still writing the book. We need people to come in and help us write, right? Because, you know, VRF, sorry, before Daikin showed up, I knew what it was. I've seen them. Am I an expert in them? No way. And nobody else in our community was that level of an expert of, you know, one of the world leaders in that whole concept, right, of HVAC systems. So,
And as all industries get more digitalized, stepping stone and harmonization capability to make building systems get to be more digital.
Yeah.
Because that
Absolutely.
just makes everything more efficient.
Yeah, I like to say, you know, data is not going away. Society as a
No,
whole,
it's not.
they did address it. They made HTML. We'd be nowhere on the web without that. Think about it, right?
Right.
Our industry, hey, we've got to face this. We've got to work together to solve it, because the future that we want for intelligent, connected buildings that perform well requires interoperable data, right? And I think that's a good point too. You know, wait a minute, John, BACnet made systems interoperable. That's right. I can connect to your system and read the data out. Minor problem. When I get it out, I have no idea what it needs. Right? What is this point? What was that name? What's it connected to? What schedule's associated with it? This is data interoperability, which is, I would say, relatively a new concept for many in our collective industries around control, automation, energy management, commissioning in the built environment.
Certainly in the built environment. It's been around more in process automation.
Yeah, but you guys never came over to
some of the
teach
other
us. You know?
manufacturing, but it's certainly there. No, exactly. Yeah.
Yeah, you didn't come over to teach us.
Very good.
We've been living in the dark. So, but anyways, you know, 10 years ago we had, you know, we started this, and you know, it's been quite a journey. It's very rewarding, but there's a lot of work and a lot of education, you know.
Well, it certainly intrigued me, and I tried to invite a number of my new associates that I've connected with on LinkedIn who are in.
Tom, I don't know if you're freezing for everyone or if it's just me.
Yeah, he's freezing for everybody, but
Yeah.
I think that's a good point. There are other standards in other industries, and what we should be able to do is at least figure out interoperability between them. We're not going to redefine the tags the industrial consortium agreed upon, but we need to understand them and see how they can work together, right? And that's why we reach out to IBPDI, difficult name to say, and others. That's just one example, and why we reached out to ASHRAE and BRIC and all those things. There's going to be more than one standard, but integrating well-defined standards is way better than integrating random mess of stuff. So
yeah, if anybody wants to share out this link once it goes out, you know, it'll be up, like I said, on our YouTube channel. So that's your opportunity to get it to anybody who wasn't able to make it today. I encourage full distribution of this. John and Mark. So John, I first met you at a Realcomm show a couple years ago, and I asked you the question about, you know, this is all great. It seems very HVAC focused. And for a group that's very multidisciplinary like this, I was asking about, you know, what is the path for developing security system tags or lighting control tags? And your response was start that working group. And
Well,
I'll admit I haven't done that yet.
Yeah, lighting, we had people from GE. There is a lighting vocabulary and taxonomy there. And as Mark said, there's a security group, and they're not just focusing on, you know, secure connection. They're actually focusing on the tagging related to security systems. So, and the good news is, as we had hoped, and I kind of claim, we believe that the methodology will apply to those systems, but you got to bring the domain knowledge in about what vocabulary and what relationships we need. That's what the working groups do. The methodology has proven to be highly extensible.
Yeah, as a multidisciplinary group, I'm just kind of curious for what is that time frame or just kind of horizon for incorporating some of those things. Is that something to look forward to in Haystack 5? Do those get folded in as they get ratified into Haystack 4?
Haystack 4 was a advance of the technology model. What you're talking about are new systems that should fit in that. Okay, And there is no time frame. The time frame is the working group getting together and how efficiently they want to work. That's one of those things, because again, there's no paid employees, and the board of directors does not drive this. We manage the organization as a legal entity, financial entity. It's the working groups that drive this forward. If nobody raises their hand on VRF, it ain't getting done, right? So those are the things. This is a really different thing for our collective industries to have to solve. Nobody handed it to us. We've got the methodology, we've got reference implementations in, I think, 10 different programming languages now. But the groups have to come together to work on ensuring the vocabulary is there. I mean, even other types of systems, you know, they have the same basic elements most of the time, right? I don't think a lot of, you know, in the VRF group, I mean, they may have come up with 4 or 5 tags that they want to add, right? The main thing they're working on is the taxonomy and the relationships, right? Figuring that out. The vocabulary, yeah, you can add a word that's not a, you know, so a big gap, I would say.
And I know that you don't know everywhere that this is deployed, but I think you have enough interaction with the community to know where it's being adopted in general. Where are you seeing this? Is this something that's mostly, you know, in the United States? Isn't it geographical, or is it Europe or Australia? Some of those places that might be a little further ahead on their building automation.
You know, you know, as we set out in the beginning, it's global, and that's, you know, yeah, it's North America, it is Asia Pacific, Australia, you know, Korea, Dubai, Abu Dhabi, Europe, and things like that. So, and, you know, if I was a betting individual, in addition to NASCAR and football, I would bet that we probably are short on that 30,000 instances of it deployed globally. We just, as John said early on, we don't know. There's no requirements to come back and say, hey, I just, you know, brought online 2 new buildings and there's Haystack is involved with that. We don't know. So
no, we don't know. But the people, the companies who, you know, I showed you the picture of the companies who are, you know, they, you know, we got together and, you know, help us understand where you see it being used.
where is it? Yeah.
You know, a conservative, very conservative number. We want to never overstate. I wouldn't be surprised if it's over 50, but we use that for now. So
I feel like it's me and Tom asking all the questions. I encourage anybody else to venture out and ask anything that might be in your mind. All right, I've been told that anything over 8 seconds of silence is awkward. So
well, that's good. We appreciate the opportunity, and I think it's great that you recorded this for your group. People who didn't. I hope it's helpful to them, and you know, we really appreciate the chance to tell people about it, and you know, please consider getting involved.
yeah, no, we're grateful for your time. I know you guys are coming over from the East Coast, so it's even later for you than it is for some of us here in the Midwest. But thank you so much. This has been a topic that's been on our list of things that our membership has been interested in since the very first meeting we had over 3 years ago.
Wow.
Kind of went around the room and let people put on their list, you know, what is it that compels you to participate in a group about intelligent buildings? And this is one of the things that people were interested in and excited about. So I'm glad that we've gotten around to being able to get the experts in the room here. And just fun trivia here, Mark. I kind of gave input into this group. He's been an honorary member since before we even had a group put together. And I was asking him for a little bit of advice. He said, serve cocktails, people will come. And
Absolutely.
that was true. But I know you've just been very generous with your time, your knowledge, and your network. Started connecting us around with a lot of other people. And I thought that's just fantastic. So hopefully the rest of us can take, you know, from following that lead and you know, be equally as generous. So thanks,
Thanks.
John and Mark, and we can wrap this up. Everybody have a great rest of your day and good weekend coming up here.
Appreciate it.
Gentlemen.
Thank you, guys.
Excellent work.
Talk to you.
Appreciate it. Cheers. Bye.
Thank you.
Thank you.